Hello. Today, we're going to talk about dividing polynomials. So this concept here, if you think about it, dividing is kind of the opposite of multiplication, right? So I think a good way to start this lesson is to first multiply two polynomials, and then I'll show you how to reverse that process. So the first thing we're going to have to do to multiply the binomial x plus 2 with the trinomial 2x squared plus 5x plus 3, we're going to have to distribute, right? So I distribute the x. That's going to give me 2x to the third plus 5x squared plus 3x, right? And then you distribute the 2. So that's going to give us plus 4x squared plus 10x plus 6. So I distribute twice and then combine like terms. 2x to the third has nothing to combine with. But I can do 5x squared and 4x squared, right? So that's 9x squared. I can combine the 3x and the 10x to get 13x, and then plus 6. Okay. So let's just think about what we did, right? I took two polynomials, one binomial and one trinomial, right? I multiplied them together, and the result was this polynomial, right? It's got 4 terms. It's a cubic polynomial because the highest exponent's 3. So, if I multiplied these two polynomials, wouldn't that mean that these polynomials are factors of this one? Just to, clarify. Remember, if I did 2 times 3 and the result is 6, that means 2 and 3 are factors of 6, right? 2 is a factor of 6, 3 is a factor of 6. Which means I could do things like this. 6 divided by 2, and that should give me 3. Or I could do 6 divided by 3, which would give me 2, right? Well, couldn't I take this same concept and then just translate it to this? So here's what I mean by that. I'm going to take this polynomial, 2x to the third plus 9x squared plus 13x plus 6, right? And I'm going to divide that by x plus 2. So I'll put these in parentheses just so you can see. I'm taking the polynomial I got and I'm dividing it by one of its factors. So, the way we're going to have to do this is we're going to have to use long division. Now, real quick, let's review long division. I know you probably haven't even seen that in a very long time. So, let's say I had a number like 126, and I wanted to divide that by 3. How would that look if I used long division? Don't I put 3 on the outside, 126 on the inside? And then I start thinking like, okay, does 3 go into 1? It does not, right? Does 3 go into 12? It does. 4 times, right? And then you do 4 times 3 to get 12, and then you subtract, right? You do 12 minus 12 gives you 0, and then you bring down the 6. So then you ask, how many times does 3 go into 6, which is 2? So I put a 2 here. 3 times 2 is 6. Subtract them. 6 minus 6 is 0, right? So that means 126 divided by 3 is 42, right? And real quick, let's do one more of those. What if I needed to do 243 divided by 6? 243 divided by 6. Again, 6 into 243. So I try 6, does not go into 2. 6 does go into 24 though, right? So I take 24 divided by 6. I'm going to do that off to the side. 24 divided by 6 is 4. So put a 4 up here. And then do 6 times 4, which is 24. Subtract them. Cross out, you get 0. Bring down the 3. Now, does 6 go into 3? It does not, right? So I have to put a 0 here, right? Because 6 goes into 3 0 times. And that means I have a remainder, right? A remainder of 3. For now, that's all we need to worry about. That a 6 goes into a 243 40 times with a remainder of 3, right? I had 3 left over, right? Think about it. 0 times 6 would be 0. 3 minus 0 is 3, and then that's your remainder, right? So the idea of long division, notice kind of what I'm doing. I divide parts of the problem, right? I only did the 24 and the 6. That got me 4. So after you divide part of it, you then multiply and then subtract. Bring down the next one and go through the whole process again. So you divide, multiply, subtract, bring it down, repeat the process. Right? Divide, multiply, subtract, bring down the next piece, and then do it all over again. So let's see how this would work using polynomials. So since I'm dividing these two, the way I'd have to structure it, I'll have to put x plus 2 on the outside and 2x to the third, 9x squared, 13x plus 6. So, in order to work this problem out, remember what we did before. We divided a part of the problem, right? Like when it was 6 into 243, I took the 24 only, right? So here's the way that it works. first part of this polynomial is 2x to the third. So what I'm going to do is I'm going to take the first term, let's make this a little longer here. I'm going to take the first term of this polynomial, 2x to the third, and I'm going to divide it by the first term of this polynomial, x. So look at what I did. I took 2x to the third, the first term, and I divided it by the first term on the outside. Now the result of that is going to be 2x squared. So what I'm going to do, above 2x to the third, I'm going to put 2x squared. Because that's how many times x goes into 2x to the third, right? So after I divide, I then have to multiply, right? The only thing is, when I multiply, I'm multiplying 2x squared by the binomial x plus 2. So the result of that, right, 2x squared times x is going to be 2x to the third. And 2x squared times 2 is going to be plus 4x squared, right? Now, I have to subtract. But you have to be careful. You're subtracting an entire binomial here, right? You're subtracting 2x cubed plus 4x squared. What that means is you have to distribute the minus sign. So it's 2x cubed minus 2x cubed. Won't that just cancel out? Then it's 9x squared minus 4x squared, right? Minus 4x squared. So 9 minus 4 is 5x squared. So I divided the first part. I then multiplied by that result. And I then subtracted. The next thing I have to do is bring down the next term, which is 13x. Now I repeat the process over again. So I'll take the first term, 5x squared, and I'll once again divide it by the first term on the outside, x. And that result is 5x. So 5x, positive 5x, is what I'll put up here. Now 5x, I then have to distribute, right? So I multiply now. 5x times x is 5x squared. 5x times 2 is going to be 10x. So, let's take a look at what we have now. So, 5x squared plus 13x, 5x squared plus 10x. I'm going to have to subtract again. So here we have 5x squared minus 5x squared. Once again, that's going to cross out. 13 minus 10 is going to give me 3x. And after I have 3x, bring down the next term. plus 6. So 3x plus 6, I'm going to have to take the first term, 3x, divided by the first term, x. So if I were to do 3x divided by x, that result is a 3. So that means I will put a plus 3 here. And one last time, I'll have to distribute the 3. So 3 times x is 3x. 3 times 2 is positive 6. You then subtract 3x minus 3x. Cancels out. 6 minus 6 cancels out. So the result is 0. There's no remainder. So what that means is that the result, right, of taking 2x cubed plus 9x squared plus 13x plus 6 and dividing it by x plus 2, look at what you get. 2x squared plus 5x plus 3. Isn't that what we had over here in the first place? Because these two things, when you multiply them, are supposed to equal this polynomial, right? Because I multiplied them to get this, that means if I divide by one of them, I'll get the other. Now, one thing to say about this process, the most important part of this is making sure that everything is lined up. Notice the whole problem. When I had an x cubed, it lined up with an x cubed. When I had an x squared, it lined up with an x squared. Do you notice the 13x and the 10x? All my x squareds are in one column. All of the x's are in one column, right? It has to be that way because we're subtracting polynomials, right? Remember, you can't subtract terms in a polynomial unless they have the same exponent, which means you have to make sure you always have the same exponent in a particular column. I want to show you an example where it's not set up for you already, and I'll show you where the issues are going to lie. So let's do another example. So, what if I wanted to take this trinomial, 3x to the 4th plus 6x squared minus 3, and I want to divide that by x plus 1. Now, based on what I was just showing you, you might think that it goes like this. Right? You take the 3x to the 4 plus 6x squared minus 3, put it inside, take the x plus 1, put it outside. So let's try to follow that same process and see if we hit any roadblocks. So we take the first term, 3x to the 4, divided by the first term, x. And that gives me 3x to the 3rd. So that's what I'll write up here. 3x to the 3rd. Then distribute that, right? So 3x to the 3rd times x is 3x to the 4th. And 3x to the 3rd times 1 is 3x to the 3rd. Then you go and you try to subtract. 3x to the 4 minus 3x to the 4, that's going to cancel. But 6x squared minus 3x cubed. You cannot subtract an x squared and an x cubed. That's a roadblock, right? I can't do this subtraction because I didn't make sure I lined everything up. So, let me show you how we fix the problem. I'm going to have to erase everything. So I'm going to restart that problem. We're still going to have x plus 1 on the outside, but watch what I have to do here. Do you notice that in this polynomial, in the trinomial, you're missing some exponents? It goes from x to the 4 to x squared. We skipped right over x cubed, right? There is no x to the third. And then it goes from x squared to just plain old 3, a constant term. Do you notice we skipped over x, which would technically be x to the 1? Well, what we have to do is we have to fill in the missing exponents. And it's actually pretty simple. So 3x to the 4. Now the next exponent would be x to the third, but we don't have one. So here's what I do. I put plus 0x cubed, because 0x cubed would just become 0, right? Which means it would be gone. But at least I'm now representing the x cubes. I then bring the next part, 6x squared. And then again, I don't have an x term, so I'll put plus 0x and then minus 3. This is going to fix all of the issues I had before. So I take the same polynomial and I just fill in the gaps, right? The missing exponents are taken place by zeros. So let's go through the problem. First term, 3x to the 4 divided by x. That's 3x cubed, right? We already knew that. So I'll take that term and distribute it and get 3x to the 4th plus 3x cubed. And then you subtract that, right? So 3x to the 4 minus 3x to the 4, that cancels out. And now I can do the subtraction. 0x to the third minus 3x to the third. That's negative 3x to the third, right? 0 minus 3, negative 3x cubed. And then I bring down the next part, plus 6x squared. Go through the process again. Take the term, negative 3x cubed, divided by that first term, x. So the result of that would be negative 3x squared. Which means this next term is minus 3x squared. Then distribute it, right? Negative 3 times x, negative 3x to the third. Negative 3x squared times 1, negative 3x squared. I then have to subtract it. Now keep in mind, you are subtracting negatives, right? So negative 3x cubed minus negative 3x cubed is technically negative 3x cubed plus 3x cubed, right? Minus a negative. Either way, negative 3 minus negative 3 is going to cancel out. And then it's 6x squared minus negative 3. Minus negative will become plus. So it's really 6 plus 3, 9x squared. You see that? Now I bring down the next term. In this case, it's just a positive or plus 0x. Repeat the process. 9x squared divided by x is 9x. So plus 9x, distribute it. 9 times x is 9x squared. 9x times 1 is plus 9x. Subtract. 9 minus 9, that cancels out. 0 minus 9 gives you negative 9x. Bring down the last piece, minus 3. So I'll take negative 9x, divide it by the first term to get negative 9. So I'll put minus 9 up here, distribute it. So negative 9 times x, negative 9x. Negative 9 times 1, negative 9. So when I go to subtract, again, negative 9 minus negative 9 cancels. Negative 3 minus negative 9. Basically negative 3 plus 9 gives me 6. Now at this point I'm done, right? There's nothing else to bring down. That means I have a remainder. And for our purposes, all you're going to do is put remainder 6. So when I did the division, I just go through this whole process, but at the end, if there's a remainder, I just put remainder 6. This is about as complicated as it could be. It's not really that hard, right? You're just doing the same process over and over and over again. Really, the hardest part is probably going to be making sure that you keep things lined up, that you fill in the spaces if you're missing any exponents. And I guess the last one I would like to look at is this question. I'm just asking, does 2x plus 3 divide into this polynomial? The only way to figure that out is to try it, right? So I'll put 2x plus 3 on the outside, and then 6x cubed plus 4x squared minus 10x minus 8. And we'll just go through the process one more time. 6x to the third divided by 2x is going to give me 3x squared. So 3x squared is my first term. Distribute it. 3 times 2, 6x to the third, 3 times 3, 9x squared. Then I subtract. 6 minus 6 cancels. 4 minus 9, negative 5x squared. Bring down the next term, negative 10x. Now at this point, I have to take that first term, negative 5x squared, and divide it by 2x. The result of that is going to be negative 2.5x. So I'm going to put negative 2.5x. I got a decimal. That's okay. Let's take negative 2.5x and distribute it to see what we get. Negative 2.5x times 2 is going to be negative 5x squared. Negative 2.5x times 3 is going to be negative 7.5x. I then subtract negative 5 minus negative 5 cancels. Negative 10 minus negative 7.5, or negative 10 plus 7.5 is going to give me 2.5x. Bring down that last term, 8. So then I have to take 2.5x and divide it by 2x. So 2.5 divided by 2 is going to give you 1.25. So plus 1.25. Distribute. So 1.25 times 2x is 2.5x. Now 1.25 times 3 is going to give me what? 3.75? And then you have to subtract. So 2.5 minus 2.5 cancels. Negative 8 minus 3.75 is negative 11.75. Since I reached the end of the problem, that means I have a remainder. So a remainder of negative 11.75. Because there's a remainder, that means this does not divide into the polynomial. The decimals themselves would not have messed me up if I ended with a 0 remainder. That would mean it does divide into it. If you divide something and get no remainder, that means it divides evenly into it. Since I did get a remainder, that means it does not. So the answer to the question, no, it doesn't. So that's really it for this lesson. I mean, it's essentially just this, right? I just wanted to make sure I went through enough examples that you really kind of saw exactly what this is about. But at the end of the day, you take the first term, divide it by the first term, right? First term inside divided by first term outside. That result you will distribute and subtract. Bring down the next term, divide, distribute, subtract. Bring it down. Divide, distribute, subtract. Bring it down. Divide, distribute, subtract, bring it down. That's all you do. Again, just make sure you fill in any blank spaces with exponents that you may be missing. That's it. Number of the day for this lesson is 56. 5, 6. 56 number of the day. Got it?